We will discuss here the unit circle and the relationship between the linear and angular measures of a central angle in a unit circle. At the end of the lesson, you will be able to illustrate the unit circle, the radian measure, the intercepted arc of a central angle, and the relationship between the linear and angular measures of a central angle in a unit circle. What is a unit circle? If a circle has its center at the origin of the Cartesian plane and its radius is equal to 1 unit, then it is a unit circle. What is radian? Radian is a unit measure of central angles. When can we have 1 radian? Let's look at the illustration. The unit circle has a central angle theta and it intercepts an arc of length s. If the length of the arc s is equal to the radius of the circle, then we say that the central angle theta is equal to 1 radian. Let us investigate further in the following slides what is theta in radian measure when theta is fully rotated in a unit circle. In a unit circle, r is equal to 1. If s is equal to r equal to 1 unit, then a unit circle has 6 equal arcs of length equal to s plus the length of the arc QA or AQ. What is the length of the arc AQ? Since the circumference of the circle is computed through the formula C is equal to 2 pi r, then the circumference of the unit circle is 2 pi. With this, we can find the measure of the arc AQ. Since 2 pi is approximately equal to the product of 2 and the approximated value of pi, which is 3.14159, then 2 pi is approximately equal to 6.28318. This clearly shows that the arc AQ is approximately equal to 0.28318. What I am trying to emphasize here is that the circumference of the unit circle is equal to 2 pi. Solved through the formula C equals 2 pi r and through the idea of theta equals 1 radian. We will use these facts to know what is theta in radian measure when theta is fully rotated in a unit circle. Generally, when we find the length of an arc intercepted by a central angle theta, it is through the product of the measure of the central angle theta in radian measure and the measure of the radius r. Consequently, the central angle theta in radian measure is the quotient when the arc length s is divided by the radius r. The arc length s is the linear measure. The central angle theta is the angular measure. Remember that one full rotation in a circle is 360 degrees, or we can say that theta is equal to 360 degrees. Earlier, we derived that the circumference of a unit circle, denoted by s, is equal to 2 pi. Since the central angle theta in radian measure is equal to s over r, then by substituting the exact values of s and r in the unit circle, we have the central angle theta equal to 2 pi radians. Definitely, when a central angle theta is fully rotated in a unit circle, theta in radian measure is equal to 2 pi radians, is also equal to 360 degrees. Thus, the linear measure of arc length s is equal to the angular measure of central angle theta in radian measure. That is, in a unit circle, the central angle theta 2 pi radians is equal to the circumference S, 2 pi. Thank you.